Okay, so today our topic is functions. All right, and define a function. So here's our definition of a function, okay? Right there. Every x value is paired to exactly one unique y value, okay? So here's our little latte stand example. Let's put it now mathematically, okay? So you drive up to a latte stand, and today you buy one for $3 and get one free, okay? So this is Emma. Emma came up to the latte stand. Here's our price, $1, $2, $3, right? And then we could buy one latte or two lattes, okay? Now, these are called my independent variables or my control variable, okay? This is my control, and this is my dependent. Control, because I get to control how many lattes I buy, right? So the control variable is always on the horizontal, okay? The control that I get to control, do I want one latte? I want 5 lattes? I don't know. I get to choose, right? But what's dependent on what I choose is the price. Does that make sense? So the price is dependent upon what I choose. I control the number of lattes, and the price is dependent on it, okay? So the dependent variable, in this case, is the price. So far, so good? That makes sense? So the control variable is all, or independent variables here. Dependent variables always on the vertical axis. Okay, so if we go ahead and graph this, Emma, I think we can have a dot here, and we can have a dot here. Does that make sense? You guys agree with that? So if you buy one latte, it's $3. If you buy 2 lattes, it's still $3. Okay? Does that pass the vertical line test? Does this pass the vertical line test? Yeah. You're never going to be able to draw a line through either one of these and vertical and hit it twice. Okay? So is this a function? Yes. Yes, this is a function. Okay? Awesome. Okay. Now here's crazy Mr. Davies latte stand. Okay. Keisha's going away thinking he is crazy. So let's see why this is a crazy latte stand. Well, okay, you're at a latte stand, order one latte. The teller tells you it's $3 and $4. Graph this function. So we've got, $1, $2, $3, $4 and $3. And we've got one latte, 2 lattes, 3, okay? And this graph should look like this and this. And it doesn't make sense. Can't have 2 prices for a single latte. It just doesn't make sense. But what I want you to see is what we call the vertical line test. So if I were to draw a vertical line, it hits it in 1, 2 places. So it fails. This is not a function. It's not. Okay, so then again, let's go back to our definition. Our definition. Okay, you guys ready? I'm going to slide it down. Every x value is paired to exactly 1. Every x value is paired to exactly 1. That's not paired to exactly 1, is it? This x value is paired to 2 different y values. It's not a function. Thumbs up. Pretty easy, the definition. Understand why? Okay, great. Let's keep going, because I don't think a function is hard. Okay, now, example 2. A couple of ways to do this, all right? 1, is this a function? Well, just by looking at the points, would you say yes or no? Okay, why do you say no?
Because there are 2 points that have a 1 and an x value. Or, wait.
You almost said.
Sorry, there's 2 with 3.
Yes, 3, the value of 3 is paired to 2, the value of 3 is paired to 1. Now, if you don't see it, the easiest way to do this, if you don't get us to graph it. Okay, I can do that. Very good. So, if you don't really quite see it, but there is the number 3, the x value of 3 is paired to 2 different things. But let's just graph it. If you're not sure how to do this, just go 1, 2, 3, 4, 5, 2, 3. Okay, so we'd have a point at 3, 2, 4, 1, 5, 3, and 3, 1. Okay, and so right here we have a problem. Okay, this is not. It's not a function because you have one x value, the 3, paired to 2 different y values. If we're to draw our vertical line, right, it's going to fail our vertical line test. So no, it's not. No. Okay. Pretty easy so far. Thumbs up. It's a pretty simple concept, isn't it? Okay. Okay, example 4. What do you think? Is the first one a function? Luckily, Leora already answered this question. Yes or no? Function? Yes or no? Yeah, and we can just draw our vertical line test anywhere you draw it, it's going to pass. It will never touch the graph twice or more. Never, okay? How about example 2? Luckily, Laura already answered this question. Yes or no? No, because any, like this x value here would be paired to 1, 2 different y's. It will fail the vertical line test if you go boom, boom, anywhere. So all these places it's going to fail. So the answer is no, it's not a function. How about the third graph? It's not. Good job, Sarah. So Sarah, why do you say it's not? You're right.
There's 2 points.
It's right here, right? Now it's going to pass. It's fine here. And it's fine here, right? So this is no. And so when we're going to do these graphs later. This is a no. And when we do these graphs, we're going to try and do it more like this. Same kind of graph. But we would do a graph like this. What's the difference besides the fact I put it in the wrong spot? What do you see, Simon?
The bottom point is empty, so it doesn't include.
God, you guys see that? This is what we want to get to eventually in this class. Here in about a week we'll talk about these, but if you draw that line, passes through, so this would pass the vertical line test. So that open circle means you're okay. Okay? Good, nice job, Sarah. Okay, turn the page. Okay, last one. Okay, so, is it a function? Yes or no? I think it is a function. I think it is a function. I think you can go ahead and graph if you want to, but every x, they're all unique x's and they're all paired to unique y's, so I'm going to say yes, it's a function. Now the domain. The domain is all the x values, okay? So my domain in this function is simply going to be 3, 5, 7, and 9. The domain is just simply all the x values. Okay, just those. And the range is simply all the y values. The y values are 1, 0, 9, and 23. 23 set. There we go, 23. Order isn't important. You could have gone this as 0, 1. Okay, you just need to list them. Does that make sense? You see what I'm saying? That the order is not important here. You could put 0 first. Okay. All right. Hate to give you homework over the weekend, you guys, but I'm just a slave driver. I know. Page 47, but it's pretty easy assignment, okay? 2, 8, 12, 13, 14, 24, and also then page 39, I want you to do 32 and 33. Okay, we have time. It's only 11. We got time to get some stuff done. So I know, I've been working you hard today, aren't I? I'm working you hard. But then I want to talk next week about doing rockets. So, oh no, I want you guys to do, yes, I want you guys to do, let me get this here. Yeah, I want you guys to do rockets. I'll have the other class do hot air balloons. Or we want to go the other way around. I don't want to go the other way around because it's cool in the morning for hot air balloons. Hot in the afternoon for rockets, right? But I want to start a project next week, okay? Something fun, all right? After I give you back the quizzes, right? Okay, guys, let's go ahead and get started on this. Page 47, okay? Yeah. Do I have sticky notes? I don't. Paperclip, yes. Sticky notes, no. Paperclip, I do, yes. I'm not a sticky note person. Oh, there you go. What do you want? Sticky notes or paperclip? I mean, either you are or you're not, right? Some people love sticky notes. Yeah. I always find that when I tried them, My desk was full of sticky notes, and I was like, I can't do that. Oh my goodness, I forgot to stop the recording.